Okay. Let's go back. Okay, I'm going to shut this off. And we're going to talk about cortical I/O and semantic folding. So just to be clear, I work for Numenta, a company called Numenta. And cortical I/O is a partner of Numenta. They were our first partner. And we have known them for a very long time. Francisco Weber founded cortical I/O. Look at that neat graphic. That's cool. Squirrel. Anyway, so we've known him. He's visited Numenta a long time ago, and so let's watch this video about what they do. So they don't actively use HTM in their current products, but how they build their products and like what they do with them is based on the properties of SDRs that we're always talking about in HTM. And what they've built is something that could definitely, is already sort of positioned in a place to be used by HTM systems as sort of I think of it as almost like a Rosetta Stone. You know, you can use this. This is like a communication medium, the thing that they've set up here, so that different systems can learn in different, using different representations and communicate. I feel like as a consensus reality. I'm always talking about the three different types of reality: internal reality, consensus reality, and external reality. I like to think of cortical I/O and these retinas that they're creating as sort of a way that we can use as a consensus reality for agents, for intelligent agents that have their own internal realities, could use cortical I/O as a sort of consensus layer to communicate concepts. So let's talk about what this does. So yes, I'm going to watch a YouTube video with you.
Semantic folding.
This is happening.
How cortical I/O
I'll turn it up for you.
Into semantic fingerprints.
Do you hear that okay? Or is that too loud?
Using the brain as a model. The neocortex is a two-dimensional sheet
So
of
first of all,
continuously repeating.
Okay, I'm going to pause and we're going to keep going. The animator who worked on this is the same animator that has helped me with things. So like the cortical column animations came from this. You know, I said I want to start from this brain model, and the ones that I use in HTM school and the ones that we use in some of our other marketing videos, we use the same animator. So I just wanted to point that out. I liked what he did here.
Neocortex is a two-dimensional sheet of continuously repeating modular assemblies of neurons.
So it's certainly more complicated than that. You know, as we break it down into a sheet, this is showing one layer essentially. So this is simplifying it by making it look like there's just one layer in there, but there's not. It's lots of layers.
That process all sorts of information like language, visuals, and sounds in a consistent.
But it's a good representation of all those different, the same circuit running
data
over
format
lots of
called
different
sparse distributed
contexts.
representation.
I'll shut up.
SDRs are very long binary vectors with only a few bits active at the same time. Each active bit bears some semantic aspect of the overall message, which is distributed across the representation.
This is a great visualization, you know, that because it'd be great if you could have, you know, a bigger area here, but that whole transition of like going
Aspect
from
of the
cat to
overall
cat,
message, which is distributed across the representation.
Well, a little bit different, but you know, when I do the scalar in HTM school, when we talk about scalar encoding and the RDSE, when you move it a little bit, that's what it looks like. Just moving it a little, because you're barely moving through the cat spectrum, you know. So
as each bit has a specific meaning, the activation of the same bit in two SDRs indicates that they are semantically similar in at least one aspect.
So it's crucial to understand this if you're going to understand how HTM works. So if anybody doesn't understand this type of representation and how you can semantically represent reality using this type of representation, raise your hand, and I'll totally take questions, explain it, stupid questions, any questions, because this is like the gateway drug to HTM, is understanding semantic sparse distributed representations. Because this really is the way the memory in your brain works, is based off of this. I'm 100% convinced this is the language of the brain, or the memory storage format of the brain. Super, super important to get this.
Generating the semantic map.
None of this stuff is biologically based. It's a
First, reference
technique they
literature
used
is selected in order to define the semantic space.
to create. I mean, when you give a word in a language to Cortical IO's API, it gives you back a representation like this, a sparse distributed representation, and through the retina. And you can have many retinas. So you could have different languages for retinas, or different subject matter for the retina could only be trained on some certain subject matter in a certain language. Excuse me. But the process of creating that retina is still, it's not representative of how you learn information. It's more of like, they're sort of doing spatial pooling in a way. Well, yeah, the biological counterparts for SDRs are neurons. So if you think about an SDR, every bit, we'll go back. I'll come back to this. This is important. Every one of these bits is a neuron. And also, okay, imagine if you're looking at one of these, ignore one, say you're just looking at one of these, and you're a neuron, right? And maybe this is one of your dendritic segments. So that's also an SDR. Each of your dendritic segments is an SDR, right? And there's going to be a sparse activation along those segments. There's going to be sparse activation along the concatenation of all of your segments, There's SDRs everywhere, but all the bits, all representing neural activity. And when you have an SDR, you've basically, that's like a receptive field in some way, or of a neuron. That's like what the neuron observes. So this, you could think of this as a receptive field, or and as also each one of these being a synapse to another neuron, or being the representation of another neuron at the end of that synapse. So these are all neurons. Yeah. This bit, how they do this, they wrote a paper about it. I haven't read it in a while. But they're sort of doing pooling.
In the parsing step,
they're doing like a semantic pooling
is
here.
cleaned of all non-text elements.
But not in a temporal way at all, right? That's the thing. This is not temporal.
The remaining text is cut into meaning-based slices called snippets. The snippets are distributed over a two-dimensional grid in such a way that snippets with similar meaning are placed close to one another, and dissimilar snippets are proportionally distant from one another.
I was very
Similar
impressed with this
snippets
video.
are those sharing a certain number of terms. The resulting grouping by topic is called a semantic map. Each snippet is associated with a pair of coordinates that defines its position on the semantic map. Generating semantic fingerprints. For each word contained in the collection of snippets, the system examines all snippets to find those that contain that word.
So it goes and gets, however it defines snippets, and now it has context for that word.
When a snippet contains the word, the coordinates of the snippet are set to 1 on an empty map. When the positions of all snippets that contain the word are activated, the semantic fingerprint for that word has been created. The semantic fingerprints of all words form the entries in the Semantic Fingerprint Dictionary. Let's look at a simplified example. When the term organ is converted to a semantic fingerprint, snippets with similar meanings activate bits that are close to one another. Different meanings of the term organ form clusters that are easily discernible.
See how spatial pooling is happening with in their method? They're doing this. They're doing it in this snippet. So they're identifying the context, like the subcontext of the different snippets you can see by the groupings in the SDRs they create.
When text that is longer than one word is converted to a semantic fingerprint, the system first converts each word of the text to an individual semantic fingerprint. These word fingerprints are then aggregated and sparsified.
See how the temporal context was just completely removed there? Just so you understand.
The aggregated
that's how you
fingerprint
lose
is
the
cut at a level
temporal
called
context
the
in a sentence.
sparsity threshold, so that only 2% of the bits remain active. This is how the final text
But you can get a fingerprint of a whole
obtained.
sentence, or a whole paragraph, or a whole book.
With semantic
a complete
fingerprints,
document. You can
similar
get a
meanings
fingerprint for
look
it,
similar.
which is really
and
cool because you can tell what it's about, right? Just by looking at the clusters in the map.
Different meanings look different. To learn how Cortical I/O solves previously baffling issues related to natural language understanding, visit us at cortical.io
go.
or try our demos.
We're going to see their demos. So let's look at the demos they have up here. If that still works. Yeah, free tools. So there's stuff you can do on the web page, and then there's Iris. So let's first do extract keywords. So automatically extract keywords from a text or from a web page. Okay, so let's go find a web page about hot field networks. We'll just go to the Wikipedia page for hot field networks and see what it says. Extract keywords, paste a text or URL, submit. So I assume it's doing what they said they were going to be doing. Couldn't have done the same with unions. Well, these are unions. Like the SDRs you get back is sort of like a union of all the snippets. I think it's still loading. There's also Iris, which if this doesn't work, we'll use that. Let's get rid of our snake photos. Okay. Just closing some things. Close. Oh shoot, this doesn't seem to be working. What if we just select all, copy, and paste it right in? I don't know. Text. Load. Now it says generating fingerprint. The aggregation has weights. The aggregation, those aren't weights, those are just stacks. They're just it's just stacks of binary activations. So they're not weights. You just set a threshold to filter them out. So I got a fingerprint. So what do I do? So there we go. Terms located at here. Random, variables, convolution, converges, integrals. So each one of these represents a, what do they call them? A snippet, right? And so now I can actually look through the fingerprint at these little groupings and tell what those snippets are about. Approximation, algorithms, iterative, random, integer, digits. So I wish there was a way to research. point, topology, differentiable, contextual, information, factual, accuracy, cognitive. Interesting. If the word organ is used in several files, the stack seems higher than the other words. Yeah, but it doesn't, I don't think that matters if the stack's higher. You still choose a place to cut it off and cut it off there. It could be just as high as when you cut it off, that you're losing information that doesn't matter, I think. Okay, so that worked, and I don't know what, look, it highlighted some things in here. In the input, it highlighted. That's weird. That must be, I wonder why those are highlighted. Are those like related terms? Those are probably terms located in the SDR. But why wouldn't Hopfield and network and connections and all that's highlighted, I wonder. So this is pretty cool. You can just go to this website and do this. Oh, those are the keywords. Keywords. So that's probably just based on these. Maybe these are the groupings here. Kachi. What is Kachi? Protein, MAPK, homology, homolog, histone, heterodimer. Heterodimer. Amino, activator, protein. Okay, so now we're relating to really biological terms over here. Nucleotides, mRNA, mRNA. Neuronal mutations. I wish I could zoom in and see that, but okay, so that was extract keywords. Let's do compare text. Okay, let's take an example of an author. Let's say Stephen King example prose. I don't know. Writing style of Stephen King. Or I should just. That's not what I should do. Who should I should just go get like a. Let's just go to a scientific Wikipedia page, like pyramidal neuron, and go to that Wikipedia page, and then go to another Wikipedia page for like chicken soup. Is there a Wikipedia page for that? Yeah, okay, chicken soup. So, I don't know. Let's just take the first paragraph of each and compare the text here. Chicken soup, it's text. Or we could just, the URL didn't work last time, so, and then here we'll do the pyramidal cell. I have no idea. This shouldn't have anything in common, right? I don't think I'm gonna have to take this out, but let's try it. What's common between pyramidal neurons and chicken soup? Biological? Combined. Randomized coronary drug dosing, chemotherapy, overdose, addicts, bowels. Oh, so there's only 24% overlap, which is not much at all. So here's like one of them, competition, knockout, competitions. So perhaps, which is a pretty orthogonal term to chicken soup and pyramidal neuron, but maybe there's some documents out there that talk about competition, soup competitions, and pyramidal neuron competitions. Manager, 3rd Division, West Ham, Tottenham Hotspur, relegation, Dundee United. That's so weird. So these terms are so far apart from each other. The overlaps seem to be pretty random. So what if we let's not put. Okay, so there's this really good soup that I recently had. Tom Kha soup. Tom Kha soup. Tom Yum. Tom yum, that's close enough. I'm gonna see if the URL one works here, because I'd rather put the URL in. And let it do the thinking. Please work. Okay, so now we got 2 soups, and there's 74% overlap. 10 minutes to what? And then so the combined terms here, naval station. what is this stuff here? They must like, there's a big group of overlap between chicken soup and tom yum. Providers, ISPs, Internet Explorer, messaging, malware. I don't know what's going on there. There's a bunch of software terms. Why are there that's weird. JPEG width, file caption. I'm trying to find, like, there should be some food. There should be food. Communities, charitable. Here it is. Hearty mustard, mushrooms, oven, onions. So here's all the food grouping. All this other stuff is so strange. There's, up here I just saw coriander. Oh no, that was down there. I don't know. It's, I assume, I mean, this is coming out of the retina. So they should be stripping all the HTML out. But let's try it. Let's take like the whole first section here and just paste it in instead of this text, and then the whole. Well, I guess it's just this one. It's a little smaller, but it shouldn't matter. 74% overlap to 51% overlap. And so the overlaps are all in these terms. Food, chefs, beverages. Okay, so this is like food industry terms. That's more what I would expect. And here are like biological animals or foods. So this overlap, this makes much more sense. There must be something wrong with the way they're processing URLs. Because that was odd. All this stuff. There still is some. So that's weird. So this means this is what used to be up here was all of those software terms. This makes much more sense. Water, desalination. Interesting. Okay, so we did compare text. Detect language. This is going to say English. Yeah. Detect the language. Detected language, English. Disambiguate terms. So let's select example. Apple. I think the orange boxes were the overlap, and the other bits were not overlapped. Okay, so this is for Apple, and so it gives us the context of it. Software, fruit, hardware, recording, tree, or sales. So let's talk about the fruit. And then it shows us the bits, I think, that represent fruit. Yeah, this is the software. These are the hardware bits that are really close to the software bits, aren't they? Think of these bits are overloaded by a lot. The recording bits, the tree bits, the sales bits. Let's put in let's put in deer. So we've got deer lakes, which is must be a place. Deer animals. Deer remains. Deer habitat. Deer park. I guess there's not that many takes on deer. What about mucho? Mucho's not English. Dump. Now this is a verb, so I'm not really sure. Dear, I see what you're saying. Dear John would probably come up in some places, but I don't know if it's strong enough to be a context for the word. Dump, help. Dump, park. Dump, data. Dump, aircraft. Dump, investors. Dump, truck. I was thinking truck. Why is dump and help in the same? That is interesting. Let's do Jaguar. This is a good one because there's a car and a feline, a chassis, a race, species, software, aircraft, temple, Mercedes-Benz. Okay, now we're going to filter tweets. And then we'll look at Iris too and play with that a little. Oh. I don't know if this is working or not. An error has occurred. I'm going to do mine. Highlight. Enter your retina filter. How do I do that? Type a term here. Politics. Artificial intelligence. Tweak your retina filter. Twist still. Auto refresh. Live feed. Sure, why not? Oops, an error occurred. Shoot. Okay, I don't think it's working. Now we need to go back. Oh yeah, then there's Iris. That's where I just was. So I downloaded this and I'm gonna run it if I don't have it running. This tool was created by David Ray. Hey David, if you're watching, this is a cool tool, so thanks. I'm trying to, can I get to like your user page? I don't want to view all commits, I just want to view you. Anyway, that's neither here nor there. Okay, so this should look familiar. As you can see my tom yum soup in the background. So let's enter a word here. Let's find, well, I guess we could enter Jaguar. That would give us a fingerprint for Jaguar. And I think it says hold down L mouse button to show similar terms for positions. Aha. Oh, it's making a, oh, I'm somehow entering L over here. Hold down left mouse button. Oh, I'm an idiot. I was pressing L. I was holding down L. All right, clitoris, all right. Jaguar, that's interesting. Penis and clitoris come up there. Fiat. Okay, so then let's add another term. Let's take out the car, right? And we want to say not car, I think. Jaguar, not car. So now the car terms are gone, but the clitoris and penis are still there, so. Okay, hunting, hawks, nocturnal nests. Sporty, trim, coupes, cars. Those should be gone, right? Cars. Do I have to say cars as well? Not cars. I didn't think they incorporated plurals. Air-cooled aero pistons, piston airline injection. So do I have to say also planes? Is there some type of, so I have to say motorcycles and planes too. Planes. Not planes. Oh shoot. The dreaded null pointer exception. Crap. That's the worst. That's the worst. It's not gonna work. Maybe I can edit back. Planes. That's, I got locked up a little. Well, that is a bummer. I got locked up. Activity monitor. It's soup now. Sorry to hit you with that beat so hard just then. I didn't mean to. All right, we're back to the beats. So I can add 2 input windows. I'm still messing with this. So you can like link these together, which is one of the interesting things. 2 or more agents communicating through this. Oh crap, hold on. To answer that question, I'm gonna have to go to the whiteboard. But yeah, I have an idea. I think I have to go to the whiteboard. So here's how it could work. So say we have a retina off in the clouds somewhere. We've got cortical, IO, retina, API, whatever. And it understands some language. So then you have, and we're gonna keep this philosophical. So what you can do is you can send it a term. You can send it a term in some, wait, let me think this through. I worked this through once before, and now I'm starting to doubt my sanity. Hold on. I'm getting. All this is going to be able to do is to take some context, some term. This maybe we can call this a label. It's not even a label. It's not a label. It's data in some language. It's a what do they call it? Let's just call it a snippet. But it's essentially something used to say okay, like it doesn't, I don't get it. I've sort of, I had this worked out in my head at one point, how this would help agents to communicate, like create a consensus reality communication protocol for things. But I think they would have to be able, the agents would have to know, would have to have labels. Oh, when you confirm the snippet, okay. Yeah, there's always a delay. maybe I don't want to call this a, what you're really sending, so I want to use the example like this, cat. So some agent is off in the world, and the tricky thing is, like, he wants to communicate there's a cat to some other thing. This other agent, and this agent doesn't speak that agent's language. And let's say that's the thing, that maybe this is breaking down, because the common language is no, so all this has to know, if these talk the same language. Okay, now I'm starting to remember. So one of the things that it depends on how the retina is trained. But if we can train the retina if this one wants to communicate cat to another agent who has, and it has no idea how the internal representation of this is, or what cat means, it could tell cortical I/O to communicate cat to it, and it would send it some sparse distributed representation of a cat along with the label cat or something like that, so that this would now have a representation of what at least that thing thinks is a cat. But they both have to be pointing to the same thing, you know. So here's the thing: they sort of have to train each other. Excuse me as I work out this philosophical existential question in real time, because I thought I had this figured out at one time, but I don't think I did. So say here is a cat. How am I going to draw a cat? Cat. This is a real cat right here. There we go. Agent 1 sees a cat, and it wants to communicate, you know, to this orange agent over here, that it sees a cat, or something like that. But they don't speak the same. It has an internal representation of this cat. Like it has an object representation of cat that only makes sense to it. If it shared its object representation of cat with this agent, it's not like this agent could look up cat and know that agent sees a cat there. So there has to be something to identify. It has to say, I know this is a cat in English, right? It has to somehow, as a part of its representation, have the label cat and send it to this in order for this to send its representation of cat to this agent. So this would essentially be saying, here's my cat, and it gets the representation from here. This agent is going to have its own representation of a cat too. It's going to have an object representation, or maybe if it hasn't learned it yet, let's say that it has learned it. If it has its own representation of cat, and so there also has to be some type of linkage of this object that it's getting from cortical I/O to its representation of a cat. It's almost like a pooling. It's like we say that in a cortical column, there's lateral sharing going on, in what some of the layers that are representing the object. So this representation means a certain thing, like it classifies an object to this column, and it's communicating what it thinks this object is to nearby columns. and they're using that as a part of their representation. Like they use the neighbors. These are distal connections, that are used to help predict and identify what object is being represented. So these are all sort of intimately entwined at a cortical column level. But you can't just send this representation, which is what I'm trying to do here, to another agent that's not outside, it's not in the same brain as you. So I'm trying to think, it seems like there's a way that we could use cortical I/O to be sort of this stable representation of, as long as you know the language, you can get a stable representation, semantic representation that you can start from to make links of your object representations to these consensus object representations. Then I think that was the idea. Retina creates SDR labels. Well, you wouldn't be able, this agent would have to learn that this is a cat somehow. And it would have to learn to assign the label to its object representation. It's not going to be able to send its representation to the cortical I/O and ask what it is, because agents are going to create their own internal representations. They're not going to get it from cortical I/O. This is sort of an extra layer aside from these two realities. This is the consensus reality. We have to think of it as, I think, just a way to pass as much information as possible through a label, because this thing knows a lot about whatever it learned about the retina. It knows about all the associations. So if you can tell it a cat, it can give enough information to this agent so that it knows what a cat is, or at least if it's learned how to interface with this consensus layer, it knows what a cat is. Excuse me for a moment. I got a lunch date. I'm honestly not sure if all this makes sense. Maybe it's too much. Maybe it's too hand wavy. All right. I'm gonna wrap up the HTM chat on cortical I/O. I think we've done a pretty thorough pass over their capabilities. Now, cortical I/O also has this contracted intelligence, enterprise solution. So if you're looking for NLP stuff or the way you can apply this, they're working on that. So contact them. Tom Yum. Okay. Okay, guys, I am going to head out. I'm going to go have some lunch and take care of a few things and work on blog posts I'm writing and editing some videos the rest of my afternoon. So I will certainly see you Wednesday. I think, pretty sure there'll be a research meeting Wednesday. I can never be certain, but pretty sure there will be a research meeting Wednesday. So thanks for joining my morning this morning, and have a great day. Bye-bye.